If you've been learning about AI recently, you've probably heard the term RAG. It may sound complicated, but it's actually a pretty simple concept once you break it down. In this video, I'll explain what RAG is, why it's useful, and how it works, all in just a few minutes. So before we dive into the what, let's talk about the why. Why do we need RAG? Well, large language models, or LLMs, are very powerful, but they don't know everything. They have limitations. Their training data has a cutoff date, and they don't automatically know about your company's documents or internal policies or other information that wasn't used as part of its training. Okay, so there's definitely this limitation. No matter how smart the model is or how powerful it is, it's just not going to know about certain information. All right, so that's where RAG comes in. So what is RAG? RAG is a technique that gives an LLM the ability to look something up before it answers your question, and then use whatever information it found and use it to answer your question, right? So it's useful because it lets an AI answer questions using your information, not just what it learned during training. That means it can answer questions about things like company documentation, product manuals, research papers, legal documents, even if that information wasn't part of its training data. Okay, so that kind of talks about what RAG is, but what does it actually stand for? What does RAG mean? Well, it stands for Retrieval-Augmented Generation. Okay, so that's kind of a mouthful. Let's break it down. Let's go through each word. So retrieval. Why retrieval? Well, retrieval comes from the fact that we are retrieving information from a knowledge source that can then be used by the LLM to give a response. Okay, and then augmented. Well, what does augmented means? It means to enhance or maybe improve something, right? So what are we improving? Well, we're augmenting the generation. The generation of what? The generation of the responses. So in other words, you could say RAG is all about retrieving information to augment response generation. Okay, so hopefully that helps kind of demystify that acronym and that definition, or to make more sense of it at least. Now let's go through an example of kind of how a RAG system is set up and what it looks like in practice. Okay, so the first thing you need to do when you're building a RAG system is you need to pick a knowledge source, right? It needs to have something to be able to look up. That could be an employee handbook, that could be a project statement of work, that could be a lease agreement or a legal document. It could be anything, okay? Anything you want to give your LLM access to as a source of data, right? Usually what happens is you will need to break that knowledge source up into smaller chunks, okay? And that's actually the term that is usually used as chunk. You're breaking it up into smaller pieces. Maybe you're breaking it up by paragraph. Maybe you're breaking it up by number of words. Maybe each chunk has 500 words. It's kind of an art, and a lot of trial and error goes into how you should chunk your knowledge source. Then after you have your knowledge source broken up into many different pieces or chunks, you use what is called an embedding model to convert each chunk into what is called a vector embedding. A vector embedding is basically just a numerical representation of your text. Okay, so it's basically just a list of numbers that represents the meaning of a piece of text. And we call it a vector because it's a list or a sequence of numbers. And an embedding model is actually another type of LLM that's made to do just this thing, to convert text into numerical representations. Okay, so for example, let's say we're using the employee handbook. We want to use that in our RAG system, and we've broken it up into chunks. So maybe one of our chunks says something like, employees receive 15 paid time off days, 10 sick days, and 2 discretionary holidays. Okay, so that embedding model would take that chunk and it would turn it into something like this. And that looks meaningless. That looks meaningless to us, but to the model, that actually means something. And maybe there's another chunk in our employee handbook that says something like, the employer matches up to 50% of 401k contributions up to 6%. And then it turns it into a vector embedding that looks like this, okay? And then it does that with all the chunks. Maybe we have hundreds or even thousands of chunks, and it embeds each one of those chunks. And then after it does that, it needs to be stored in a special type of database called a vector database. There's lots of vector databases out there. Some examples are Pinecone or Weaviate or Chroma. Databricks and Snowflake both have their own vector databases called Vector Search and Cortex Search. I will actually be doing a video about using Pinecone to create a RAG system, and I do actually have a video about using Databricks to create a RAG system. So be sure to check those out. So now we've broken up our knowledge source into chunks. We've converted those chunks into numerical embeddings, and we've saved those embedded chunks into our database, okay? After you have those chunks saved into a database, you're pretty much there. So what happens next in a RAG system is you create a process, usually, programmatically, where the user will submit a question, and then the system, the RAG process, is able to do a lookup in your vector database and find the chunk or chunks that are most similar in meaning to what the user asked, and then take those similar chunks and give them to the LLM and ask it to give you your answer. So let's actually walk through like a simple example of what that might look like. So continuing on our employee handbook example, let's say the user asks, how much vacation do employees get? Okay, so before we can submit that question to the LLM, a few things have to happen. The first thing is that question, how much vacation do employees get, needs to be turned into an embedding, just like the chunks of data earlier. And we need to use the same embedding model that was used to convert our knowledge sources chunks into vector embeddings, okay? So maybe that will turn the text, how much vacation do employees get, into something that looks like this, okay? Then you do a search against the database, okay? And it's not going to be a text matching search or a keyword match search. It's going to be usually something called a semantic search, okay? And so instead of looking for matching text, it looks for meaning, similarity in meaning. So it takes that question and it tries to find the most similar chunk in our vector database to the question. And notice that the employee did not use the word paid time off, they used the word vacation. And our employee handbook doesn't have the word vacation, but it does have that chunk that says employees receive 15 paid time off days and 10 sick days and 2 discretionary holidays. Now, the semantic search is able to recognize that vacation and paid time off have a similar meaning. So it's going to flag that chunk as being similar to the question that was asked. And so it's going to take that chunk, and maybe more depending on how it's configured, it's going to take the most similar chunk or chunks and shove that information into your prompt. So what we're submitting to the LLM is something like, here's the user's question, how much vacation days do employees get? And here's some relevant information that I found in the vector database. Use this information to answer the question. So then the LLM will use that to give you your answer, and it's going to return something like, based on your employee handbook, you get 15 vacation days per year. And that's it. That's all there is to RAG. Hopefully that kind of demystifies RAG and lets you see that it's actually not that complex. The concept itself is basically just giving an LLM the ability to perform a search and then use its findings to generate an answer for you. Hopefully that was helpful. And if it was, please like this video. And also stay tuned for other videos about RAG where I actually walk you through building a RAG system.